I want to talk a little bit more about light. So here goes. Okay, I'm going to make my pen a little bigger. So if you look at the visible spectrum in terms of light is really pretty narrow. It would go from, red, dark reds to orange. I don't have all the colors to draw, but orange, then yellows, then eventually greens here, and then finally blue. And this is what we see. So this is the visible spectrum. In terms of wavelengths, red light is, somewhere on the order of 7 times 10 to the negative 7th meter. That's the wavelength. And blue light is approximately 4 times 10 to the minus 7th meter. So, the wavelength is really short. Beyond those, okay, there's still light. We just can't see it. So here, for example, you start hitting the infrared region. Past that, you get to microwaves or radio waves. On the other side of the spectrum, you end up with ultraviolet, UV, and then after ultraviolet, you go to X-rays, and then beyond that, really high energy light like gamma rays. And this type of light is called this is not very nice light. This is ionizing radiation. So light on this side of the spectrum is bad because it can kind of raise havoc. So anyway, so that's kind of the visible light, or the entire electromagnetic spectrum. Now, if I were to be moving across this, okay, in terms of a wave, I'll do a green wave. Down here, the wavelength would be really long. But as I move across, it gets shorter and shorter. Okay, until we get up here and it gets really short. So what you have is the least hazardous waves have long wavelengths. The most hazardous waves have high wavelengths. So I have a general increase in frequency as I move across too. Move from left to right. So looking at this, okay, these relationships, and those two equations that I gave you last time, C equal to lambda mu and E equal to h mu. What you find is that as you move across the relationship of energy and frequency and wavelength are this. Wavelength is inversely proportional to frequency. And energy is directly proportional to frequency. So as I'm moving across from left to right in this electromagnetic scale, okay, there is a decrease in wavelength, lambda. There is an increase in frequency, and there is an increase in energy. Okay, so kind of get those relationships down. Now I want to talk in terms of the Bohr model again. Okay, with the nucleus right here, and then I have some energy levels. I'll make them all different colors. And let's say I'm looking at an electron that's starting at the first energy level, and it's being excited, and it's jumping, say, up to this blue level. Okay, electrons that originate in these lower principal energy levels have a high attraction to the nucleus. So it's going to take a lot of energy to get that electron to jump up to this point. So if I was comparing some electrons, okay, then I'm going to do another electron. And this electron is going to be initially in the blue energy level, and it gets excited to the red. Okay? And now I'm going to look at the light that comes off of this. So I'm going to look at the light that's coming off of this first electron. Well, it comes down, cascades down, goes back to where it starts off, and I see some blue light. Then I look at the light that comes off of this electron right here. When it falls back down to there, it gives off red light. And this is sort of what you would expect, because, like I said, the electrons that are situated closest to the nucleus have the highest attraction to the nucleus, so it's going to take more energy to excite them up to higher energy levels. When they fall back down, the energy that they're going to give off is going to be of higher energy, and blue light is higher energy. Whereas those electrons that are further away from the nucleus, they aren't feeling the same attraction from the nucleus. It's going to be a little easier to kick them up to higher energy levels. So when they absorb light, or absorb some energy, they're going to give it off in the lower energy bands, which would be more towards the red side. So just kind of think about that, how it goes together. That's about it.